On coordinate geometry of the line, we're going to be looking at slope, and in particular we're going to be looking at comparing the slopes of different lines. And there are two particular circumstances that I'm interested in, and the first is what happens when I have parallel lines. So here we have a pair of parallel lines, and I'm going to stick a little pair of matching arrows in them just to really make it clear that they're parallel. And you can see that both of these lines have the same steepness, or the same slope, and this is always true for parallel lines. Parallel lines always have equal slopes. So it's quite straightforward to test if two lines are parallel in coordinate geometry. We can just get their slopes and see if they're the same. So if the slope of the first line, which I can call M1, equals the slope of the second line, well then I'll have proved the lines are parallel. We also have a symbol for parallel lines, and the symbol for parallel lines actually looks like a pair of parallel lines, so it's really easy to remember. So let's look at an example. So our example says, given A, which is 4, 2, B, 5, 5, C, 0, 1, and D, 1, 4, so these are my 4 points, verify that AB is parallel to CD. Verify just means check or show, and here we see our symbol for parallel. So this just means that I have to apply the slope formula twice to AB and separately to CD, and then check and see what happens with the two of them. So I'm starting with AB. I'll make a note of my formula, I'll label my points, and then I'll substitute in. And you're well able for this yourself, so pause the video here and do that yourself, and then play and see if you're correct. So the slope of AB is 5 minus 2 over 5 minus 4, which is 3 over 1, or just 3. Now we'll do the exact same thing for C and D, and again, you're well able to find the slope of these of the line joining these 2 points. So pause the video here, do that yourself, and then play in a second and check if you're right. So I already have made a note of my formula. I'll label my points, and then I'll substitute in. And this time I'll get 4 minus 1 over 1 minus 0. So that's 3 over 1, and again I'm getting 3. So I've found both slopes now, but I'm not quite finished yet because I had to verify that the lines were parallel, so I need to conclude at the very end. And again, with a question like this, it's very important to include that conclusion, because without it, you've shown that you know that it's something to do with slope, but you haven't wrapped it up completely. You haven't shown the full information that was required by the question. So what should my conclusion look like? So I'm going to state the obvious here, that the slope of AB equals the slope of CD, and therefore AB is parallel to CD. So now here's a question for you. Again, you're given 4 points and you want to check this time to see if EF is parallel to GH. Pause the video here now, do this yourself, and then play and check if you're right. So I've written down my 2 pairs of points. I note the formula. I'll deal with E and F first. So I've labelled those x1, y1, x2, y2, and I'll fill that in. And for that slope then, I get minus 1 over 5. Next I'll find the slope of GH. So I'll label the points, and I'll fill in to get 1 minus 2 over minus 2 minus 3. And this works out as 1 over 5. Now these two answers look really alike, minus 1 over 5 and 1 over 5, but they're not the same number. So if they're not the same number, well then that means the lines are not parallel. So now I'll state my conclusion. So I'll first of all say that the slope of EF is not equal to the slope of GH. So EF is not parallel to GH in this case. So now we move on to look at perpendicular lines. Perpendicular lines are lines that meet at a right angle. And if I know the slopes of the 2 lines in question, I can check to see if they're perpendicular by multiplying their slopes. And if they are perpendicular, their slopes will have a product of minus 1. Just note here that this dot in this case represents multiplication. There's a symbol for perpendicular lines also. And again, it's a nice obvious one. It just looks like 2 perpendicular lines. So there's 2 things we're going to have to be able to do. We'll have to be able to check and see if 2 lines are perpendicular, but we'll also have to be able to work out the slope of the second line if we know the slope of the first. So let's start off with checking if things are perpendicular. So for this, I'm going to make out a table, and I'm going to call the columns M1 first of all, just to represent the first slope, M2 to represent the second slope, product, so that's the result when I multiply, and then I'll call the last column perpendicular. And if the lines are perpendicular, I'll put a tick, and if not, I'll put an X. So in my first example, I'm going to put in the first slope as 2/3 and the second slope as minus 2/3. Let's work out their product. It's minus 4 over 9. So are these lines perpendicular? Well, if they were, their product should be minus 1. That's not the case here. So lines with those slopes would not be perpendicular. This time I've got a slope of minus 3 over 2 and a second line with a slope of 2 over 3. Pause the video for a second while you find the product, and then have a think, are those lines perpendicular? Well, when I multiply these two fractions, I get a product of -1. So that means yes, the two lines with these slopes are in fact perpendicular. Try this one yourself. Okay, so when I get the product, when I multiply the slopes of the two lines, in this case, I get a result of 1, but the lines would only be perpendicular if the product was -1. So in this case, the two lines that have these slopes are not perpendicular. Next, I have two lines with slopes 7/3 and -3/7. Try this one yourself. Are they perpendicular? Well, in this case, the product of the two fractions is -1. So the lines are perpendicular. This time I have two lines. The first has a slope of -1, the second has a slope of 1. So check and see, are they perpendicular? This one's pretty easy, isn't it? Because -1 times 1 is obviously going to give you -1. Next I have 2/2. So are these two perpendicular? Well, this time my product is 1 and not the -1 that I need, so no, they're not perpendicular. And finally, what about a half and -2? If I have two lines with these slopes, are the lines perpendicular? So in this case, the product is -1, and that means, of course, the lines are perpendicular. Have a glance back through the cases where the lines were perpendicular and see, do you notice any relationship between the value in the slope 1 column and the value in the slope 2 column? Pause the video for a while you have a think about this. So you might notice something about what has happened in these two columns when I get a result of -1. Here I've got -3/2. To get the value in the second column, I can get it by flipping this fraction over and changing its sign, so changing it from a negative to a positive, and just flipping the fraction. Same thing has happened here. I've got a positive fraction of 7/3. I change it to a negative and I flipped it over. Down at the bottom here, I've got a half, so I've a positive fraction. I've flipped it over, and that's made a negative. What about this line here? Well, I could write -1 as a fraction by putting it as -1/1. It's a negative there. Change it to positive, flip it over. I end up with 1/1 again. So -1 and +1 are the slopes of perpendicular lines. And that's a handy little trick to know, because I can use that if I know the slope of one line to find the slope of the line that is perpendicular to it. So I can summarize this by saying that if two lines are perpendicular, then their slopes are a/b and -b/a. And this just represents the idea that I take the first slope, flip it over and change its sign to get the second slope. So let's practice doing this. Given one slope, let's look at how to find the slope of the perpendicular line. And again, for this, I'm going to draw a table. I'll just have two columns this time, M1 and M2. I'm going to fill a slope into the first column, and then let's see, can we figure out the slope to go in the second column if the lines are perpendicular. So my first slope is 2/5. Now, what could I fit in here to represent the slope of a line that is perpendicular to this? Well, I'll flip it over and change the sign. So the slope would be -5/2. Okay, next I've got a line with the slope of 1/3. See, can you figure out now what the slope of the perpendicular line will be? So again, I flip it over and change the sign, and it's -3. You could write it as -3/1, but -3 is the simplified version of that. Now I've got a slope of -7/5. What do you think the slope of the perpendicular line will be? Well, I flip it over and change the sign, so it's 5/7. Here I've got 4, and I want to find the slope of the perpendicular line. So I'll flip it over and change the sign. And of course, remember that 4 is 4/1. So the slope of a line perpendicular to that will be minus 1 over 4. And finally, minus 2 over 9. So take a moment to think, what would the slope of the perpendicular line to this be? So again, I change its sign and I flip it over. And remember earlier on, we mentioned that if two lines are perpendicular, their slopes have a product of minus 1. So take your calculator now and just double check. When I multiply in each case, do I get a result of minus 1? So let's see. Yeah, it works in every case. So the lines in both cases, M1 and M2, are definitely perpendicular. So here's an example of a question that we might encounter to do with perpendicular lines. I've got the point A 4, 1 and the point B minus 3, 3. I want to find the slope of AB, and then I want to find the slope of any line that is perpendicular to AB. If you're confident that you know how to approach this question, pause the video now and have a go at it. And even if you're not entirely certain about the perpendicular part of it, you can still pause and find the slope of AB. So I've written down my points A and B. I've got my slope formula, and I'm labelling my points. So now I'll substitute into the formula. And on top I'll get 3 minus 1, and on the bottom I'll get minus 3 minus 4. When I put this into the calculator, I get a result of minus 2 over 7. And then finally I must get the slope of a line that is perpendicular to AB. So any line that is perpendicular to AB has a slope of, well, I can get that again by taking the slope of AB, flipping it over and changing the sign. So in this case my answer is 7 over 2.